Good day, viewers all over the world. You are welcome to Troidel online class. So we want to look at double angle. We want to look at double angle. So double angle. We recall from addition formula. We recall that when we have sine A plus B, this is given as sine A cos B product product is commutative. So this is this same thing as sine 2a. A plus A is 2a. 2a will now give us sine A cos B, same thing as cos A sine B. So that will give us 2 sine A sine 2 sine A cos A. So under the double angle, if you have double of a particular angle, like A, angle A, we now double it. Sine 2a, the expression of sine 2a will now be 2 sine A cos A. So we should take note of that. For sine under the double angle, sine 2a is given as 2 sine A cos A. Then if you have cos, if you have cosine cos 2a, that is, if you have cos, of course, if you have cos A plus B, that is given as cos A cos B minus sine A sine B. Okay. If you now put in B to be equal to A, so if you do that, we are going to have cos, instead of A plus B, that will be A plus A. Cos 2A will now give us cos A minus sine A sine A. So cos 2A is given as cos A times cos A will give us cos square A minus sine square A. So this is an expression for cos 2A under the double angle. Cos 2A is equal to what we have on the board. This is just one form of writing cos 2A. But since we have cos square A and sine square A, so if we recall from fundamental identity, which is that sine square A plus cos square A is equal to 1. If I make cos square A the substitute formula, I'm going to have cos square A to be equal to 1 minus sine square A. So I can get another derivation for cos 2A. Cos 2A is equal to, instead of cos square A now, I'll change it to this. I'm going to have 1 minus sine square A minus sine square A. So cos 2A, I have this first expression. The first expression for cos 2A is cos square A minus sine square A. So we can also get another expression. Cos 2A can also be equal to, this is 1 minus sine square A minus sine square A, that's minus 2 sine square A. This is another expression. This is another expression for cos 2A. If you want to write cos A in form of cos and sine, we are going to have it to be cos square A minus sine square A. But if you want to write cos 2A as expression of only sine, then you write it as 1 minus 2 sine square A. Also, from this fundamental identity, if I decide to make sine square A the substitute of formula, sine square A can be equal to 1 minus cos square A. 1 minus cos square A. So if I substitute that to cos 2A, instead of sine square A here, I'll change it to 1 minus. So I'm going to have cos square A minus, into bracket, minus 1 minus cos square A. Then this will give me cos square A minus 1 minus is plus 2 plus cos square A. This shows that from this point now, we can have our cos 2A to be equal to cos square A plus cos square A. That will be 2 cos square A minus 1. This is the third expression for cos 2A under the double angle. When we have sine 2A, it has only one expression. But when we have cos 2A under the cosine, there are three expressions for cos 2A. Cos 2A, if you want to express it in the form of cos and sine, cos 2A is given as cos square A minus sine square A. But if you want to express cos 2A in form of only sine alone, then it will be 1 minus 2 sine square A. Then the third one is that when you want to express cos 2A in form of cosine alone, then it will be 2 cos square A minus 1. So these are the three expressions for cos 2A under the double angle. Then we move to tan, the tangent of the double angle. So when you have tan A plus B is given as tan A plus tan B all over 1 minus tan A tan B. Then if you put B to be equal to A, so we are going to have tan A plus A. Of course, A plus A is 2A. That will give us tan A plus tan A all over 1 minus tan A tan A. Then the expression for tan 2A, the expression for tan 2A will now be tan A plus tan A is 2 tan A all over 1 minus tan A times tan A tan square A tan square A. So this is the expression for tan 2A. So we have been able to show the expression for sine 2A, the double angles under for sine, cosine, and tangent. We have been able to show the expression for tan sine 2A. There are three expressions for cos 2A, as we have shown that. Therefore, tan 2A, this is the expression, is equal to 2 tan A all over 1 minus tan square A. So I'm going to give I'm going to give example under double angles. So I'm going to give example under double angle. So let's take example under double angle. So example. Let's say example 1. It says if alpha and beta are acute angles such that sine alpha is equal to 8 all over 17 and cos beta is equal to 3 all over 5. Find without using table. Find without using tables the first question, sine 2 alpha. Then the second one, cos 2 alpha beta. Then the third one, we have to find tan 2 alpha. Okay? So in this case now, of course, we know that if we want to find sine 2 alpha, we are going to have it to be 2 sine alpha cos alpha. So for sine 2 alpha, we are going to have it to be 2 sine alpha cos alpha. That is for sine 2 alpha. Then for cos 2 alpha, for cos 2 beta, it depends on how we want to write it. Cos 2 beta can be 2 cos square beta minus 1, or cos square beta minus sine square beta, or 1 minus 2 sine square beta. So whichever expression that we use under this, we get the same answer. Therefore, tan 2 alpha, it will be 2 tan alpha all over 1 minus tan square alpha. So let's try and get the expression. So for this first one, if this is sine alpha, if this angle is alpha, sine is opposite all over hypotenuse. Of course, we have Pythagoras triples. So if this is 17, this is 8. Of course, here will be 15. We have done that before. When you use Pythagoras theorem, if you use Pythagoras theorem, I have 17 squared to be equal to 8 squared plus this unknown, let's say x squared. This is 289. It's equal to 64 plus x squared. Then I have 289 minus 64 to be equal to x squared. 225 square root is equal to x. So x is equal to 15. So I'm going to get this to be 15. So once I've gotten the value of the third one, then I can go ahead and write the expression. Let me just write everything here. Let me write everything here. So we know sine alpha to be 8 all over 17. So we can find cos alpha now. Cos alpha will be adjacent 15 all over 17. Why tan alpha will now be tan alpha will be opposite of adjacent 8 all over 15. So we have gotten expression for that. Then we move to the second one where we have beta. If this is angle beta, we are given cos beta to be 3 over 5. Cos is 3 over 5 adjacent over hypotenuse. If I apply Pythagoras theorem here, I'm going to have this to be 5 squared to be equal to 3 squared plus say y squared. Let's call this place y. So that 25 is equal to 9 plus y squared. 25 minus 9 is equal to y squared. 16 square root is equal to y. So y is equal to 4. So here will be 4. With this now, we can actually get expression for beta. We have tan beta. Tan beta will be 4 over 3. Sin beta it will be opposite all over hypotenuse. That's 4 all over 5. Why cos beta? Cos beta will be adjacent. We are given that 3 over 5. So we have gotten expression for everything, sine, cosine, and tangent for everything. So we will now start from the first one. We are given sine 2 alpha. So how do we get sine 2 alpha? From the expression of double formula, sine 2 alpha will be 2 sine alpha cos alpha. That's what you get. And here, what is sine alpha? We have 2 multiplied by sine alpha. Sine alpha is 8 all over 17 multiplied by cos alpha is 15 all over 17. So here, if we multiply everything at the denominator, we are going to get 240 because 2 times 8 is 16, 16 times 16 is 240, divided by 17 times 17 is 289. So this will be the expression for the first question. Then we go to cos 2 alpha. So in this case now, there are 3 expressions that we can use here. Just let me go ahead and use 2 cos squared. 2 cos squared, no, beta is beta. Cos beta, we are given as cos beta minus 1. Or you can decide to use 1 minus 2 sine square beta. Or you can decide to use cos square beta minus sine square beta. Whichever way you decide to use, whichever form you decide to pick, we are going to get the same answer. Here, I'm going to have 2 multiplied by, what is cos beta? Cos beta is 3 over 5. So cos square beta will be 3 all over 5 all squared minus 1. Then from here now, from here, I'm going to have 2 multiplied by 3 squared is 9 all over 5 squared is 25 minus 1. So I'm going to get 18 all over 25 minus 1. So that is the LCM will be 25. I'm going to have 18 minus 25. So at the end of the day, I'm going to get minus 7 all over 25 as the expression for cos 2 beta. Then the last but not the least is where we have tan 2 beta. The third one is where we have tan 2 alpha. Tan 2 alpha will be 2 tan alpha all over 1 minus tan square alpha. So that's what we are going to get. So in this case now, we are going to have 2 multiplied by, what is tan alpha? Tan alpha is 8 all over 15. Then divided by, let me do the denominator, 1 minus tan alpha is what? Tan alpha is 8 all over 17 all squared. That's what we get. So that's what we are going to get. So in this case, I'm going to get 16 all over 15 divided by, if I find the LCM here, 70 squared is 289. So that will be 289 minus 8 squared is 64. That's 64. So from here, I'm going to have 16 all over 15 multiplied by 289 all over, if we subtract this from this is 5. This is 225. Okay, that's what we are going to get. So this is 225. We are going to have 225 here. So we are going to have 225 here. So if this is 225, so from here now, the LCM is 1 here is 17, but this 17 square is 289. 1 in 289 is 289 minus this is 289, then it's 74. So this is what we are going to have. we are going to have we are going to have here we are going to have 225 all over 289. This is what we are going to get. But if I change division to multiplication, then I will interchange. Division to multiplication will now be 289. If I change division to multiplication, from there now, this is what I have here. Let me just do it stepwise so that there won't be any problem. Here, I'm going to have divided by, I have 1 minus 64 all over 289. This is what I'm going to have. Then from here, we have 16 all over 15 divided by the SCM is 289. 1 here is 289 minus 64. Okay. So I will continue from here. I'm going to continue from here. So from here, I'm going to have 16 all over 15 divided by 225 all over 289. Then from here, I'm going to have 16 divided by 15 multiplied by 289 divided by 225. So if that is what we arrive at, then finally, excuse me, excuse me. So finally, we are going to have this. Then 16 times this. So this is 289 multiplied by 16. I will have, from here now, I'm going to multiply this. If I multiply this, tan alpha 8 all over 15. Tan alpha is 8 all over. That will be 8 all over 15. So if I multiply this 6 times 9, 54. I could 5. This will be 5. 6 times 8. 6 times 8 is 48. That's 53. Remainder 5. 6 times 2 is 12. That's 17. Then here I have 9, 8, 2. So I have 4 here, 2 here. We have 6, then 4. So I'm going to have 4, 6, 2, 4 all over 225 multiplied by 15. I'm going to have 5 times 5, 25. 5 times 2, 10. That's 12. 5 times, that's 6. Then I have 5, 2, 2. So I have 5, 7, 8, 2. So I'm going to have 2, 8, 7, 5. And that is what we are going to get as the final answer. So we have been able to show the expression for cos 2 beta, tan 2 alpha, and we have been able to show the expression then for sin 2 alpha. So I would love to stop here because of our time. But we have been able to show the expression for double angle. That is when you have sin 2 alpha, cos 2 alpha, depending on the angles, then tan 2 alpha. So in our next class, we'll talk about triple. We can have triple angles. We can have triple, and in that order. The general concept is called the multiple angle. So thank you for listening. If you have any further question, thank you and God bless you all.